This lecture is going to cover the ideal gas law, very similar to what we have been doing before, where we're looking at different variables, plugging it into an equation, but we're looking at a different equation here. You're going to want to have your objective sheet, your calculator, and for this you are also going to want to have a periodic table. We are going to be finding molar mass on this, so make sure that you are able to read those values. So ideal gases. What we assume is that gases behave ideally, which we refer back to the kinetic molecular theory that you learned about in the simple gas laws. Now, this isn't always true, and actually rarely do gases actually perform ideally, but this equation allows us to make pretty good predictions about what we are looking at. So now we're going to have additional variables from what we have used already. The first one is a lowercase n, and that stands for the number of moles. So that is going to be the number of moles of whatever gas it is we are looking at. And then the second one is R, and this is going to be a gas constant. So similar to the constant that you have seen with things like specific heat, except this constant is going to stay the same, as opposed to with the specific heat it changed for every substance. This is going to stay the same. However, the units of the constant will dictate the units in the problem. So you'll see what I mean. The units on R, well, R, the value is 0.0821 liters times atmospheres over moles times Kelvin. So it's very important that we recognize the units here, because if you are given a volume in milliliters, that's not going to cancel out with your liters. If you're given a pressure in millimeters of mercury, that's not going to cancel out with your ATM. If you are given grams, that's not going to cancel out with the moles. And if you are given degrees Celsius, that's not going to cancel out with your K. So it's important that we recognize that the values we use in the problem must be in liters, they must be in ATMs, they must be in moles, and they must be in Kelvin in order for units to cancel. There's also something else you're going to see a lot of is called STP. That stands for standard temperature and pressure, and these two values are 273 Kelvin and 1 atmosphere. These will not be provided for you. You should know those. However, I will provide you with R, with the value and with the unit. So you are going to get used to the R after a while. You probably won't even need me to show it to you, but you will be provided with that. You will not be provided with the STP value. So I'm going to put a red X by those. You will not be given those, but you will be given the underlined blue of the value of R. All right, so the equation. The equation for ideal gas is PV equals nRT. So P being your pressure, V being your volume, N is your number of moles, R is that constant we just looked at, and T is your temperature. Now, rearrange the equation. Do not memorize the equation, because then you're going to be memorizing 5 different equations. All you need to know is this and a little bit of algebra. So let's say we're solving for P. P would equal nRT over V. All I did was bring this V to this side. So I multiplied on the left side, which means I need to divide to move it over. So I just divided by T. Let's say I'm solving for R. It's going to be PV. No, we're not going to solve for R. We're going to solve for T. We know what R is. PV equals nRT. We're going to rearrange that to PV over nR equals T. So I was multiplying by nR on this side. So to get rid of it, I have to divide to bring it over here. Let's say we're solving for V. We'll do that in a different color. V equals nRT over P. And then the only one we haven't solved for, we'll do N here, is going to be PV over RT equals N. Now please do not try and memorize these. All you need is this magic equation here. PV equals NRT, and then all you're going to do is rearrange. All right, moving on. So we're going to do some practice problems. Determine the volume of 2.34 grams of CO2 gas at 273 Kelvin and 1 atm. So that 273 Kelvin and 1 atm should be ringing a bell to you. Those are at STP, which a lot of the problems that we're doing today will be at. So we're looking for the volume. So remember, your PV equals nRT. We're going to rearrange that to solve for the volume. So we are going to be left with volume equals nRT over P. So let's go through our different variables here. P equals 1 atmosphere. That's right here. N, we'll skip that. R equals 0.0821. Let's write all of our units down. Liters, atmospheres, mole, Kelvin. My T equals 273 Kelvin. Now, I'm left with this 2.34 grams of CO2. N stands for moles. So my 2.34 grams of CO2 needs to be converted to moles. So 1 mole of CO2 is 44.01 grams. That's your molar mass. So when we solve for that, that equals 0.0532 moles. Okay, so if you're giving grams, remember that has to be in moles. We cannot just use that value because 0.0532 is a lot different than the 2.34 up here. Okay, so let's plug everything in. Now, write out your units. I know it's something that we don't really like to do that much, but they're very important, especially in making sure that your units are canceling. So my N, just going to plug everything into this equation right here. 0.0532 moles. Start a little more over here. 0.0532 moles times 0.08 liters, atmosphere, mole, Kelvin, times my temperature, which is 273 K, divided by my pressure, which is 1.00 atms. Alright, so let's go through and cancel our units before we even start calculating. I have moles on the bottom, I have moles on the top, they cancel. I have Kelvin on the bottom, Kelvin on the top, they cancel. Atmosphere on the top, atmosphere on the bottom, they cancel. I am left with one unit, and that's liters, and I am trying to solve for the volume. So see why it's just important to make sure that we are keeping track of our units. It's really going to allow you to solve here. Okay, so go ahead, punch that in your calculator, see if you get the same thing that I do. .19 liters. Okay, easy enough. Let's move on to another one here. A sample of argon gas at STP, should be ringing a bell here, we should be thinking numbers here for that, at STP occupies 56.2 liters. Determine the number of moles of argon and the mass in the sample. So we're not just going to stop at the moles, we're going to do some solving after that. So we are solving for the number of moles, which is N. So if we rearrange our equation, I want you to pause this, rearrange your equation, and then come back. So we should have N equals PV over RT. Now, STP, we should be thinking 273K and 1 ATM. So my P is 1 atmosphere. My V, given in the problem, 56.2 liters. My R, 0.0821 liter atmospheres mole Kelvin. And my temperature is STP, so that's 273K. Okay, so all my units look okay. They're all going to cancel. So let's go ahead and plug them into our equation. So we are using this. 1 ATM times 56.2 liters over RT is 0.0821 liter atmosphere mole K times 273K. Alright, let's check those units first. Get rid of those. Atmospheres, atmospheres, liter, liter, Kelvin, Kelvin, and we are left with moles. Okay, so let's go ahead and solve. Calculate this with me. And we should get 2.51 moles. Now, if you got this number, if you got this, if you did not get this, don't worry, you typed it incorrectly. What you probably did was multiplied this, and then you divided by this, and then you multiplied by this. What you have to remember is, remember your order of operations. Please excuse my dear Aunt Sally. You're going to multiply first. You need to multiply these two together before you divide. So if you got this really big number, that's where that came from. So what you're going to want to do is take 56.2 and you're going to want to divide it by the product of 0.821 times 273. All right, so we get a mole value of 2.51, and that solves this part right here, but it also wants the mass in the sample. So if we have this many moles, we're going to want to multiply that by the molar mass of argon, which is 39 point, we'll just do 39.9. So 2.51 so you should get about 100. moving on. At what temperature will 0.654 moles of neon gas occupy 12.30 liters at 1.95 atmospheres? So we're not at STP anymore. We're not at standard temperature. We're not at standard pressure. So we're not going to use that 273 because that's what we're solving for. We are solving for the temperature. So first thing we want to do, let's rewrite that equation. So we're going to have T equals PV over NR. Okay. My P equals 1.95 ATM. My V equals 12.30 liters. My N equals 0.654 moles. And my R equals 0.0821 liter atmosphere mole. Okay. Okay, all my units look pretty good. Atmospheres will cancel, liters will cancel, moles will cancel, we'll be left with Kelvin. So now what do we want to do? We want to plug it into our equation. So my pressure times my volume divided by our N times our R. Liter atmospheres. Okay. Okay, let's cross out those units to get started. Atmospheres, moles, liters. We're left with Kelvin, which is what we want. We're solving for temperature. Okay, so 1.95. Go ahead and do this in your calculator. Especially if you did not get the right answer last time. Let's make sure we're typing these in correctly. So we get 400.7. Okay. All right. A 12-gram sample of gas occupies 19.2 liters at STP. What is the molecular weight of this gas? Now, this just says we have a 12-gram sample of this. Now, what we are trying to find is the molecular weight or the molar mass of whatever this gas is. So, what we're going to be solving for is the N. So, we need to determine the number of moles that this 12 grams is going to represent. So even though it gives you this, we're trying to solve for the N because we don't know what the mass or what the molecule is or what type of gas it is, so we can't find the moles because we don't have the molar mass. That's what we're solving for. So it's at STP, so we're looking at 273 K in 1 atmosphere. So we're trying to solve for N. Pause this. Rearrange for N for me, and then come back and check. So here's what you should be getting for N. PV over RT. Let's go ahead and write out our variables. P equals 1 atmosphere. Our volume is 19.2 liters. Temperature equals 273 K. And R equals 0.0821 liter atmospheres per mole. Okay, so you already probably know that number already. Okay, let's plug it in our equation. 1 ATM times 19.2 liters, that's our PV. R 0.0821. Times our temperature, which is STP, so we're at 273 Kelvin. Let's check those units, get them crossed out. Atmospheres, atmospheres, liters, liters, Kelvin, Kelvin. We're left in moles, which is what we want. Okay, go ahead and solve. So we should be getting 0.85, we'll do 3 digits here, 857 moles. Okay, but now what's the molecular weight, or the molar mass, or whatever this might be? So 12.0 grams, and we have this many moles. So what I want you to think about is, what are your units on molar mass? Your units on molar mass are grams per mole. So that's what we're going to do. We're going to take our 12.0 grams and we're going to divide it by the number of moles that we have, 0.857 moles. So now we'll be left with grams per mole. And we get about 14. All right, I want you to go through, try this one on your own, come back and check to see how you did. All right, here's a checkpoint. Make sure that you have the right equation written out here, and also make sure that you have the correct values. Okay, here's another checkpoint for you. Checking to make sure that your equation is set up properly, and now we'll cancel your units, moles, moles, liters, liters, Kelvin, Kelvin. We're left with ATMs. Go ahead and solve. And here is your answer. So making sure that you did your math right is one of the parts you need to double check here. So make sure you know the equation. You only need to know one. You just need to know PV equals nRT, and then you can arrange from there. You do not have to know the value constant for R here. However, you will probably already know it after using it just a few times here, but that will be provided for you. Make sure that your N is in moles and not in grams. And make sure that all of your units cancel. If you were given a pressure in millimeters of mercury, you would need to convert that to atmospheres. If you were given a volume in milliliters, you need to convert that to liters. Have to make sure that your units cancel, which is why it is important that when you are doing the equation like this, that you are including units while you're writing so you are able to make sure that they cancel. Okay, go ahead, try some practice problems. Let me know if you need any help, and good luck.